Hi, this is Dr. John Bergduff. In this video, we're going to talk about how to convert a repeating decimal into a fraction. And the way I see this, it's a 5-step process, which I'm going to show you with a couple of examples. Let's start with the number 7.36 with the 36 repeating. That's a repeating bar above the 36 as a mixed number. And also as an improper fraction. So we're going to convert it to a mixed number and an improper fraction. Now, first of all, if there's a whole number part to the number, let's just save it off to the side for now and try not to forget that it's there. I'm going to just take the 7 and put it aside and hold on to it for later. The first step we're going to follow is to let x be the given decimal number. So I'm only going to be considering the part after the decimal. And yes, that's 0.36, repeating. But what I'd like to do is write that a little bit differently to emphasize that repeating pattern. The repeating pattern means that the 36 repeats over and over and over. 36, 36, 36, 36, 36, on and on and on forever. Never terminates, never comes to an end. So that's x. That's step 1. Now, step 2, multiply x by a power of 10 to move the decimal point until it is just to the left of the first repeating pattern. This takes a little getting used to, but it's not too bad. So where are we again? We have 0.363636, etc., etc., etc. And what this is saying is I'd like the decimal point to be just to the left of the first repeating pattern. Well, the repeating pattern here is the 36. And right now, the decimal point actually is exactly where you want it to be. It is just to the left of the first repeating pattern. We don't have to do anything, therefore. We can just leave it right there. And there's nothing to step 2. Just leave it be. Already have what we want. Step 3 will sound familiar, but it's different. Multiply x by a power of 10 to move the decimal point until it is just to the right of the first repeating group. Here's my value of x from step 1. Now, what this step is telling me is I would like to see if I can move the decimal point until it is just to the right of the first repeating group, until it's right there, right after the first 36. Now, this is where we think about multiplying by powers of 10. If you multiply a decimal number by 10, it slides the decimal one place to the right. If you multiply by 100, it slides the decimal 2 places to the right. 1,000, 3 places to the right. I need the decimal point to slide essentially 2 places to the right. So to make that happen, I would need to multiply by 100. 100 times x would have the effect of taking the decimal point, sliding it until it's after the first repeating group. But I want to notice that even after that, you still have infinitely many 36s going on and on and on. So 100 times x will move the decimal from here to here. Now, step 4 is interesting. Subtract the results of step 3 minus the result of step 2. So I have right here copied down what I got in step 3 and what I had from step 2. I didn't have to do anything, if you remember correctly. I'm going to subtract those 2 statements. Now, subtract on the left and subtract on the right. What I want to focus on is what happens on the right. You've got 36.36363636, I can't even say it, forever and ever and ever. And below that, subtracting 0.363636. Notice that everything to the right of the decimal place between the top line and the bottom line lines up perfectly. So when you subtract, everything that's after the decimal point, everything to the right of the decimal point, subtracts away and goes away. So that all you have on the left now is 36. Everything else is gone. It's pretty cool. I think I said left, but I meant right, on the right. On the left, in the meantime, 100x minus x, combined like terms, 100x minus 1x would give me 99x. My repeating decimals are gone, and I have a fairly simple equation. 99x is equal to 36. Let's see what step 5 is. Solve for x. So we now have the equation 99x equal 36. We know from doing other things that it's always legal to divide both sides of an equation by the same number. So we would have x is equal to 36 over 99. Notice that that is basically a fraction. And that's what we wanted. We wanted to convert that repeating decimal into a fraction. Now if this reduces, it should. Notice that the 36 is 9 times 4. And the 99 is 9 times 11. So x is equal to, once we divide out the 9's, 4 over 11. Now, let's look back and see where we were to begin with. I'm going to back up a little bit. So notice in the beginning our value of x was just the part of the decimal that follows the decimal point, the 0.36 repeating. There was a 7 that we need to not forget about. Let's bring him back in. The 0.366 that was x, we now know that that could better be written as 4 11s. So our mixed number is 7 and 4 11s. 7.36 repeating is the same as 7 and 4 11s. Now that gives me a mixed number. And if you remember right, the instructions said write it also as an improper fraction. That's found by taking the 11 times the 7, add the 4. 7 times 11 is 77, plus 4 is 81. So this is also 81 over 11. So, mixed number, improper fraction. That's how you take a repeating decimal and convert it into a fraction. Just to make sure that process is clear and to show a couple other little things, let's do another example. Here my number is 0.345, and I hope this is clear, but the repeating bar is only over the 4-5. So we start step 1 by letting x be the decimal number, but to get a really better feel for what's going on, I'm going to write it not with the repeating bar, but showing how the 4-5 gets repeated over and over and over. Not the 3, it's not part of the pattern, but 0.3, 4-5, 4-5, 4-5, 4-5, 4-5, 4-5, so on and so forth. Now step 2 may have seemed like a kind of silly before, but it's going to make a little bit more sense here. Multiply x by a power of 10 to move the decimal point until it is just to the left of the first repeating group. Here's x from the previous step. What I want to happen is I'd like to move the decimal point until it's right there, but well, that's not clear enough. Right there it's better, between the 3 and the 4. So the decimal point is going to slide until it is just to the left of the first repeating group. I need that decimal to be one place farther to the right than it is right now. I can make that happen by multiplying by 10. Multiplying by 10 will move the decimal point one place to the right so that it is just to the left of the first repeating group and becomes 3.4545454545, etc., etc., etc. Now we're going to hang on to that. Now step 3 is a lot like step 2, except we're going to multiply x by a power of 10 to move the decimal point until it is just to the right of the first repeating decimal group. So I would like to move the decimal point until it is after the first 4 5. Right there, in other words. In other words, I've got to slide that decimal point 3 places to the right. To get that to happen, I'll have to multiply by 1,000. So 1000x would move the decimal point 3 places to the right until it's just to the right of the first repeating group. And I would have 3 4 5 point. And remember that although I've kind of moved this over, there are still infinitely many 4 5 4 5 4 5 patterns off to the right. All right, let's see what step 4 says. Subtract the results of step 3 minus the results of step 2. So the top row is what we got at the end of step 3. 1000x is 345.4545454545, etc., etc. The second row is what we got from step 2, which was 10x, and that was 3.45454545. Now notice that if you follow step 2 and 3 correctly, everything to the right of the decimal place is going to line up. And because those 4 5s go infinitely far to the right, all of that will subtract off. Everything to the right of the decimal place will subtract away. So that on the right, if I can imagine this, all of this is going to go away. All of this is going to go away. All that's left is 345 minus 3. And that would be 342. In the meantime, you combine like terms on the left side. If you have 1000x minus 10x, you would end up with 990x. So 990x is equal to 342. Now, that's going to make the final step work out fine. Here's what we had at the end of step 4. 990x is equal to 342. Solving for x is simply dividing both sides by 990. And you can see when you do that you're going to end up with a fraction, and that was the goal, to have a fraction. Now the fraction we may reduce, we'd like it to reduce. So I'm going to remember some of my my tricks for divisibility from another place. And notice, for example, that if I add up the 3, the 4, and the 2 in the numerator, 3 plus 4 is 7 plus 2 is 9. That sum is divisible by 9, so 9 must divide into 342. And 9 more clearly will divide into 990. To be exact, and I can use a calculator on this, the 342 is 9 times 38, and the 990 is 9 times 110, which means the 9s will divide out and give me 38 over 110. Let's go to the next slide. X is equal to 38 over 110. But because both of those numbers are even, you can see they should both be divisible by 2. In fact, 38 is 2 times 19, and 110 is 2 times 55. The 2's divide out. 19 is prime, so there's no way this is going to simplify any farther. We get 19 over 55. And if we remember all the way back to where we started, because it's been a while, we were originally looking at the repeating decimal 0.345 with the repeating pattern over the 4/5. What all this work tells me is that that repeating decimal converts to this reduced fraction. Cool process, almost like magic. Hope you like it. Take care. Bye-bye.